Okay, just on this one, when you do this one, this is part 2 of sections 4, 4, and 4, 5. Don't forget the cube root. You can write it as a 1/3 power on the whole thing, right? On the whole thing. Okay, so I'll leave you those to work. Let's go on to number 3. This is still section 4. All right, and number 3, the example says log base b of 2 is approximately 0.256. Log base b of 3 is approximately 0.406, and log base b of 5 is approximately 0.594. And we're going to use those to estimate letter A, log base b of 10, and letter B, log base b of 9. And C and D, I will leave to you. C is log base b of 30, and D is log base b of 15 over 2. Okay, so A, log base b of 10. So what do I want to do? Well, I want to write this in terms of 2s, 3s, and 5s. I want to write the 10 itself. So this log base b of 10 is like log base b of 2 times 5. Okay, according to the rules that we just saw, this is log base b of 2 plus log base b of 5. Yeah, log base b of 2 is, according to this, 0.256 approximately, plus log base b of 5 is 0.594. Yeah, and if we were to combine those, 0.256 plus 0.594, let's use a calculator, make sure we get it right. 0.256, 0.594, and add, I get 0.85. Okay, so that's approximately 0.85. Okay, all right. Let's try letter B. Log base b of 9. So I want to write this in terms of 2s, 3s, and 5s. Well, I can write that as log base b of 3 squared. Okay? I could have written it as 3 times 3. It will not matter. Then this will be 2 times log base b of 3, which will be 2 times log base b of 3, I'm told, is 0.406. Yeah, that'll be approximately 0.812. So log base b of 9 is approximately 0.812. Notice I'm not looking for what b is. Okay, not the objective, right? It's just I'm just using the information that I'm giving to find some quantities. All right, let's go on to the change of base formula. You might see a little proof of this. So let's see what it says first. So let x a not equal to 1 and b not equal to 1 be positive real numbers. So they're all positive. Just a cannot be 1 and b cannot be 1. Then log base a of x can be written as log base b of x over log base b of a. Let's look at a proof first before we use it. So how can we do that? So I'm going to start with the following. Log base a of x can be written, it's some number y, right? Log base a of x is some number y, and that means a to the y equals x. Okay, if I take a to the y equals x and take some log of some base b, that's going to be log base b of a to the y equals log base b of x. I'm going to bring the y power over to the coefficient, so this will be y times log base b of a equals log base b of x. And if I solve for y, I will have y equals log base b of x over log base b of a. And I go back now in y, remember, is log base a of x, so I'll replace y with log base a of x. Then is log base b of x over log base b of a. Okay? Notice that b is my own choosing as long as it's a legitimate base for a logarithm. Okay? So log base a of x is log base anything that I want of x over log base a anything that I want of a. Usually, by the way, I want base 10 or base e, which is ln. So I can then take log base a of x and say that's log of x over log of a, or ln x over ln a, and whichever one will give me the same answer. As an example, well, let's do the example. Heck. So let's look at log base 2 of 7. The instructions are estimate each between 2 consecutive integers and then use the change of base formula and a calculator to approximate each to the nearest 1,000. So log base 2 of 7 what is that between? Well, we can check by looking at powers of 2. So 2 to the second is 4 and 2 to the third is 8. Notice the exponents are 2 and 3. So log base 2 of 7 is greater than 2 and less than 3. That means somewhere between 2 and 3, right? How do I know that? Because log base 2 of 4 is 2 and log base 2 of 8 is 3. Okay? And log base 2 of 7 is between log base 2 of 4 and log base 2 of 8. Now, how do I find an approximation? Well, log base 2 of 7, I use the change of base formula. I was going to use, let me see which one's easier for me here, ln. So I'm going to take, you can use ln or log base 10. So it'll be ln of 7 over ln of 2. And you could also write it as log base 10 of 7 over log base 10 of 2. And it'll give you the same number. Which will be approximately, and if I ask my calculator, that's ln of 7 is about that much, and then ln of 2 is about that much, and I'm going to divide the 2, and I get 2.807 to the thousands, approximately 2.807. And look, if I take 2 to the power 2.807, 2 to the power 2.807, I get 6.998, which is really close to, did you guys see that? 6.998, which is really close to 7. Yeah, of course that's because we rounded. All right, so that confirms that I have a good answer. All right, let's look at some graphing. All right, so first let's look at the graphing f of x equals log base 2 of x by plotting points. That means substituting values of x. So let's try starting at, it can't be 0. Let's try 1. Log base 2 of 1. You remember some of the properties we saw earlier. Log base 2 of 1 is 0. So x equals 1 gives me y equals 0. X equals 2. Log base 2 of 2 is 1. Y equals 1. Log base 2 of 4 is 2. All right. Log base 2 of 3 somewhere in there, between. Log base 2 of 8 is 3, kind of off the graph there, off the grid. All right, log base 2 of 1/2, so at x equals 1/2, that's -1, right? Because 2 to the negative 1/2 is -1. 2 to the negative 1 is 1/2, I'm sorry. Log base 2 of 1/4 is -2, right? Because 2 to the negative 2 is 1/4. Log base 2 of 1/8 is -3, so it's getting closer to the y-axis, but it never gets there. Yeah, so remember that's called an asymptote, right? It's going to get forever infinitesimally close to the y-axis, and then, okay, there's my sketch. All right, and we're going to leave graphing f of x equals log base 2 of x minus 3. So I graph f of x, log base 2 of x, and you're going to graph f of x equals log base 2 of x minus 3. Remember, this is just a shift. Also, it's not a vertical shift, right? It's just a shift. You'll have to decide where, and you can try plugging in a couple of points just to verify that you're on the right track. Okay, so I'll let you finish the other examples there. Let's go on to section 4.5, and we'll start it off. Okay, so exponential and logarithmic equations. So some properties we're going to use. So b to the x equals b to the y is the same as x to the x equals y. If b to the x equals b to the y, we can say x equals y. Or if x equals y, we can say b to the x equals b to the y, as long as they're legitimate possibilities. If we have log base b of x equals log base b of y, we can reduce that to x equals y. Or if x equals y, then we can say log base b of x equals log base b of y. Again, assuming that the quantities are defined. And then finally, log base a of x equals y. Remember, we can rewrite that as x equals a to the y power. X equals a to the y power. Okay. So to solve exponential or logarithmic equations, in general, we can follow these steps. We isolate the exponential or logarithmic expression. Check if both sides can be written with the same base. If not, use properties to rewrite if necessary. Solve and then check. Let's try the even ones, 2, 4, 6, and 8. The examples and the other ones will be for class. Okay, so number 2 says, 5 to the x equals 50. So the first thing I want to try to do is write 50 as a power of 5. So I can have 5 to the x equals 5 to the something. But I can't, right? 5 squared is 25, 5 to the third is 125. I miss it. So if I can't do that, I'm going to take a log with the same, make sure that the exponential is isolated, and take the log base, the same base that is there. So it's 5 to the x, so the base is 5. So I'm going to take log base 5 of 5 to the x, and that'll be the same as log base 5 of 50. And I can take log any base, by the way, any base I want. All right, so log base 5 of 5 to the x is just x, so x equals log base 5 of 50. Now, I'm okay with that. Some people like to rewrite this as log base 5 of 25 times 2. Then they separate it into log base 5 of 25 plus log base 5 of 2. So you get 2 plus log base 5 of 2. Okay, same thing, does not matter. So that's an exact answer. If I want an estimate, then I just use my calculator. And I can use my calculator. I can use the change as base formula. So x will be log of 50. Again, notice I only want to do this if I'm asked for an approximation. Over log of 5, which will be approximately, or ln, either one. Okay, 50. I get 2.431 approximately. Notice this to the nearest thousand, and I just decided on the nearest thousand. Whatever they ask me to do, I'm fine. Okay, so that means 5 to the 2.431 should give me pretty close to 50. I'm going to check that just to make sure. 5 to the 2.431 gives me 50.026. So that means I'm good. All right, let's try number 4. Oh, I think I'm going to stop my video here. All right, so we'll pick up on the next part.